everybody, and welcome to a new quick video. This time we're going to talk about golden master testing, and we're going to use two libraries, approval tests and FsCheck, to make our job easier. In order to get started, I'm going to take a look at a kata. It's a little, for those of you who don't know katas, those are little programming exercises you can use to try out new stuff, to get better at things like unit testing, refactoring. And today we are going to use the Gilded Rose refactoring kata to introduce these two new tools. Let's open up the repository. So Emily Beige has a lot of katas in her GitHub, and one of those is called Gilded Rose. Let's scroll a bit down and find the description. I think this is the one. Yeah. So a quick problem description. We have been employed by the Gilded Rose, and the Gilded Rose is a small inn, and they sell stuff, and they need some kind of inventory tracking system that keeps track of the quality of their items they have in stock. All items have certain properties, like a quality that goes down, a sell-in value that goes down, and the quality and sell-in decrease every day. So that's the problem statement. There's some really nasty business logic and edge cases because this is real life. And now a new feature comes in. So we're asked to implement conjured items, and these have a special rule set saying that they degrade in quality twice as fast as normal. So that all makes sense. You're an eager programmer and you want to get started. Well, in comes the code. Code is pretty nasty. So I'll open up some code. This is the Gilded Rose code, and it's pretty hard to follow. There's a lot of branching. There's a lot of nested conditionals, so it's 1, 2, 3, 4, 5 levels deep. So it's pretty interesting to figure out where this new feature of conjured items would have to land in this method. So we are asked to implement this new feature, but we are going to refactor the code a bit first to make it easier to add this feature in. It's a bit like the saying from Kent Beck: first make the change easy, warning, this may be hard, and then make the easy change. We have another challenge or another problem. This is the entire project code. So we have Gilded Rose. This is the system, the business system we want to test. And we have another class called item. It's just a property bag containing the name and the quality and a sell-in value. And that's it. And when I'm saying that's it, I mean there are no tests. So when we start to refactor this piece of code, we have no safety net to catch any mistakes we make. Code without tests. It's called Legacy Code in a very good book. It's this one, Working Effectively with Legacy Code by Michael Feathers. And he defines legacy code as code with afraid change or code without unit tests. So today we're going to add tests around this thing in order to safely refactor it later. We're not going to do the actual refactoring today. We're just going to show a way of easily adding regression tests around a piece of legacy code. And the strategy we're going to use is called a characterization test. It's also straight from the book. I'll maybe read like the definition. The characterization test is a test that characterizes the actual behavior of a piece of code. So we're not designing any new code. No, we're just trying to make sure that we catch the current behavior of a piece of code inside a test. And that's called the characterization test. And he also has a little process in here, like how to write characterization tests. It's a 5-step process. It's really simple, and it goes like this. First, you use a piece of code, so we will have to use this Gilded Rose .updateQuality method. Then we write an assertion, but we don't know the expected behavior yet because it's really hard to follow code. So we just do some kind of idiotic assertion, like assert that the empty string is the same as the actual output. So that will fail by definition almost, or I hope that will fail. And then you have the output in the error message. You can copy paste that into the expected step, and then you have your unit test for the current behavior. So that's the broad strategy we're going to apply here today. It's called Characterization Test, but we're going to use a very specific flavor of characterization tests called Golden Master. Let's drop back to the slides real quick. So our goals for today are to get this code under test with minimum effort and with a maximum safety net for any possible regressions we might introduce during the refactoring. Cool. We are going to use the technique called Golden Master testing. And the process of a Golden Master goes a bit as follows. You generate a whole lot of random input data. So in our case, that would be the items for the quality management system. Then we run the Gilded Rose behavior with this deterministic large set of input data. It has to be deterministic. That's a really important part because you have to run and rerun this test and you would like to get the same output every time. So that's why it has to be deterministic. But it can be random in the sense that you don't have to think about the cases all that much. You can just generate a whole lot of items with all kind of different names, all kind of different qualities, stuff like that. And you hope you cover enough. When you run the system with this huge set of data, you can capture the output. And in realistic legacy code scenarios, most of the time it's log files or events going out or messages on a messaging infrastructure. But you can capture, for any kind of system, you can capture most likely some kind of output. And if you can make that output the same every run, like you strip away timestamps, strip away irrelevant data like that, and just have like a textual representation of the expected output, you run it once, you save that output on the first time, you, of course, take a look at it, so you're sure that it represents a valid case, and then you save that output to a file or somewhere. You save that expected output, and that's called the Golden Master. So that is the truth. This is the output we expect every time we run that test. And then when you start refactoring and you start rerunning this test, you can run that test and compare the current output against that first initial Golden Master output. And if there's any differences, you know you broke something, and you can start to diff the two files or the two outputs and see what kind of thing you broke actually. So that's the broad idea. We're going to be using two libraries to make our job easier today. One is called approval tests, and I think it's almost the de facto standard for Golden Master style testing. Approval tests is a library that allows you to do diff-based testing. So I'm just going to show you in a minute or two. It's a bit abstract to explain, but basically you just write a test and you say, approve me this output. First time you won't have any output, so it'll just pop up a screen saying, is this what you expect? If you like the output you see, you can approve it, and every subsequent test run of those tests will compare the current output with that initially approved output. So you will notice any differences. The second library we're going to use is one I encountered when I learned F#. It's called FsCheck, and it's a library for property-based testing. Property-based testing is a complex topic in and of itself, but we won't go really into the property-based aspects of FsCheck. We're going to use a little part of it, and it's called generators. So generators basically are a way to generate data of any type purely at random on the fly without having to write any code ourselves. So we can generate random numbers, random strings, but even more impressively actually, you can generate custom data for custom types. So for example, in the Gilded Rose kata, we have that item class. We can leverage the FsCheck Generator library to generate random items for us. And this is exactly what we're going to do today. Alright, let's get started. So I pulled in Gilded Rose and I threw away all the dependencies just to make a point. So we have no NuGet packages, nothing. We just have code that compiles. There we go. Step one is I'm going to pull in those two NuGet packages. Let's first install approval tests. There we go. Let's install FsCheck. There we go. And next, let's install some kind of unit test framework. My favorite framework du jour is XUnit, so let's just go for that. Okay, we've installed everything. I'm gonna write a quick hello test to make sure everything is up and running. So let's write a new class. I'm gonna call it Golden Master already. There we go. Let's write a new test. Okay, my shortcuts are not working. That's not a problem. Let's handwrite it. So let's write a new test. Public void. No useful name just yet. And let's make sure our tests are running and failing the way we expect them to. There we go. So this should fail. We have a failure, yeah. Expected true, actual false, that is correct. Let's make a pass just to see we have a green test as well. So yeah, XUnit, we have XUnit up and running. Next step, let's check if we have approval tests up and running. So let's do a very basic system under test. So we have, for example, input is hello. And let's write some business logic, for example, reverser. And that's what we are going to test, is a function that takes a string, and returns the reverse of the string. Oh my god, is this something? Yeah, I'm making things too difficult. Say we're going to do input is a number, and we're going to calculate something. It's the number plus 5. I'm doing something completely random right now. But say this is my test input, and this is some kind of behavior I'm testing. Right now it's hard-coded inside the test, but just for illustration. And then we're going to use approval tests to verify the behavior. So let's go to the approval test namespace and do approvals.verify. Can it take a string? Yeah, it can take basically anything, even object. I'm curious to see how that works actually. But okay, for the demo, we're going to use approve, and what are we going to verify? We're going to verify the output, and we call this variable result in here. So this is our first approval test actually. We have some input, we call some code, and then we verify the results. We verify the result. That's really weird because normal unit tests have this compare this to that and make sure they're the same kind of thing. Here we just say verify result. Let's try to run that. And it fails as expected, and it's actually a cool error message because it's very self-explanatory. We forgot to do something, or no, sorry, I forgot to do something, and the test is just, the failure message is just saying hello, welcome. It's a really friendly API, cool. But it's saying, okay, please add this attribute to your class, method, or assembly. Why? It's even explaining why we should do this. It comes down to approval tests uses your diff tool of choice to present any kind of failures. So if an approval test starts failing, it will really open up a diff tool and say, look at what's changed. So it's really cool, and we're going to show it later. But it's saying we have to take this attribute and put it on our test or our class or whatever. So I'm going to do that. Yeah, I'm just going to take that over literally. I'm going to rerun this test now. Yeah, and now it's opening the diff reporter, so it's opening the diff tool Visual Studio knows about, and it's saying we have a .approved file, so this is the golden master file on our right, and on the left is the current run, and it's saying, whoops, it's failing because we don't have an approved file yet. So what you normally do is you take the input from the first run and you paste it into the approved file. So now you're saying like this test, and how do you know it's this test? Because it's the class name dot method name of the test dot approved, and this is what approval test will look for when running subsequent tests. So now we have this file run.approved.txt somewhere in our solution, and let's pull it in to the code solution explorer as well, so we can have easy reference to it. It's a text file, so we should be able to find it this way. There we go. So this is the golden master file for this specific test, and we expect the output of this thing to be space 6. I don't know if this space is going to be what I expect. Let's see. So no, we have a space where there should be none. There we go. So I changed the .approved file, and now it should be green if everything goes well. There we go. So now it's green, and every time we run the approval test or this test, we will do the diff, and if it's okay, it's green. If it's not okay, we will get a diff pop up in our face showing the differences. So say we are refactoring this really hard piece of code right here, and instead of adding 5, we subtract 5, and let's rerun it. So we now introduce the bug. This is what we will get. So this is what we got this run, -4, but we used to have 6, so something changed. And this is the power of approval tests. We just wrote these 3 lines, and we can have very broad regression tests around any kind of code where we can capture some output, which is great. So let's fix that test again, make it green. This was the principle of approval tests, and we're going to use this to wrap a golden master test around the Gilded Rose. Next up, let's try running Gilded Rose. So let's go to the Gilded Rose code and see how we can run this behavior. Gilded Rose is a class. It has a constructor that takes a list of items, cool, and it assigns that list directly to some kind of private property over here. And then there is this method, and this method contains behavior we're interested in. So we want to start refactoring this, so we need tests around this kind of behavior. Some interesting aspects about this method. 2 interesting aspects around this method. 1, it does not take any arguments, so it will work on the internal state probably. Yeah, it will work on the items list. And 2, it's a void method. Void methods are side effects, so it will do something to the internal state probably. And as you can see here, yes, it is updating quality of items in that array, so it is actually producing side effects. Okay, let's try to execute this method. So what do we need to execute it? We need Gilded Rose, so I'm just going to call it Rose is new Gilded Rose, and it takes a list of items. Let's just provide an empty list to get started. Now we have the Rose, and Rose has a method update quality. That's it. Let's comment this out for a second. So now we have a Gilded Rose, we can provide items, and we can run behavior, and then we could actually verify stuff. How can we verify stuff? Well, let's say we extract this list. There we go. And then we can, for example, approvals.verify the list of items. It's not going to be very interesting right now because it's an empty list. So let's see. It's even toStringing the list, so that's not actually what we want. But we'll get there. We'll fix that in a moment. So this is the approach we're going to take. We're going to generate a huge set of items. We're going to feed it through Gilded Rose. We're going to trigger the behavior, and then we're going to check whether the items have been updated accordingly. Cool. I'm going to do this for one item first, and we're going to hand write the item just to get a feel of what we're doing here. So let's make a list of items. Well, what am I doing? That's not even necessary. There we go. Let's add an item to this list. So we have an item. Let's give it a name. It has a name, my magical item. We'll give it a random quality because we don't know anything about the problem domain just yet. So we're just going to give it something. Some value, same story. Don't really even know what it means. So we have an item. We run the Gilded Rose behavior over it, and then we're going to verify this. This is still a list, and we don't like to see the toString representation of the list type, so let's capture the relevant item information. Let's call it output is items.select. We're going to map over the items and toString them basically. So toString the item. Now we have a list of strings. Yeah, a list of strings. Maybe that's even good enough for approval tests. Let's try it out. So approve the output, and that's a list of the item information. Let's quickly go to the toString method we already had, and it's printing the name, comma, selling value, comma, quality. Cool. Run this approval test. Nope, this was not enough. So we still have an enumerable instead of a string, and approval test does not like it. So let's go back to our test. And we have a list of strings here. Let's just join that together with string.join, new line separator, and as values we take what we had here, so the item details. And now we have a single string where every line in that string is item information. This should probably be better. There we go. So my magical item has a sell-in of 19 and a quality of 12. So it seems like it's ticking down both when we call update quality. Okay, let's prove this by copy pasting what we have this run, and if we rerun the test now, it's green, and if we rerun the test again, it's green again. And this is basic golden master principle. I'm gonna run unit test coverage really quick to show how much of the code we're currently covering with this one single my magical item case. So with this one single case, we are covering 36% of the behavior. So let's highlight it and go to Gilded Rose. Every line in green is a line we are executing when we're running our unit tests. So it seems like we're falling into this branch to decrease the quality, but not a lot else is happening. Oh yeah, over here we are also decreasing sell-in, but there's a lot of edge cases we are currently not executing. So this single test would not really provide much of a safety net for all the behavior in there. So let's grow our items bucket or list our items. Let's add more items so we cover more of the test. And there's two strategies for this. One is to start inspecting the code, inspecting the coverage, and seeing, okay, what kind of items do I need to have the test execute this branch? And that's a really interesting exercise as well, and it will help you gain business knowledge by like reverse engineering the code. But there's an easier, or no, not easier, there's a faster way, and you don't have to think that much to get the test around it, and that's what I'm going to show you today. And we are going to generate a whole lot of items, and we're going to generate them randomly using that FsCheck library. So we don't even have to think that much and get a list of 10,000 items, no problem. So FsCheck. What is FsCheck? Property-based testing library, already said it, but we're just going to use the generating of random data part. I'll give you a quick rundown on FsCheck. I'm going to use the C# interactive REPL to show you. The beginning API for generating data is arp.generate, and you provide a type parameter like int. There we go. So this statement is a generator for ints. If you hover over it, the type is gen of int. So this thing knows how to generate random ints. Sorry, I'm going to play around a bit with this in the REPL so I can show you what this thing actually means. And for that, I'm going to load in the FsCheck DLL into the REPL. Need to drop down to I need to find the DLL for that. So let's go to my binaries over here. Is that a good way to do it? Yeah, sure. FsCheck.dll, that's the one we want. So copy paste my path and require that in here. FsCheck.dll. So first we load the DLL into the REPL, and then we open the namespace. So I'm just going to run this in the REPL. Now we know about ARP and stuff in the REPL. Cool. And now I can send random C# to the REPL. There we go. And now we have this generator to play around with. So this is the an actual generator. There we go. And FsCheck provides some utility functions to troubleshoot generating, and that's what we're going to use to play around with it. I'm sorry, I just hit my mic real hard. So there is a method called sample, or a function, and you give it a size, more on that later, but just let's give it something, and number of samples, that means like how many of this do I want. So generator is a gen of int, and I want, let's say, 5 random integers. If I run that, it gives me a list of 1, 2, 3, 4, 5 random integers. So this is basic FsCheck generators. And this is just an int, but you can use it for strings, for bools, for characters, for any kind of data. And what's really interesting, you can use it for custom types, so classes you write yourself. Let's give that a try. I'm going to write a class, public class. What are we gonna design today? Coffee. We're gonna design some coffee. What does coffee have property-wise? Let's give coffee a name, the bean. Yeah, and let's give it an integer property. Let's give it a strength or an intensity level. So higher intensity level means stronger cup of coffee. So this is a class coffee. I'm going to send it to the REPL as well. There we go. So now I can play around with coffee in my REPL. There we go. Let's make some coffee ourselves. New coffee. Name is Arabica. I know nothing about coffee, so I'm sorry if I'm inventing new kinds of coffee here. So, okay, now we have coffee, but instead of generating or calling constructors manually and generating a whole lot of coffee, let's use the FsCheck generators. So to do that, you do arp.give me the generator for my type, so the coffee generator, and let's call it gen. There we go. Now gen is a generator. Yep. And we can sample some coffee. Let's say we want to have 3 coffee objects, and it gives you 3 coffees. One with a very lucrative name, PR7- with an intensity of 3, intensity of -3, called U ASCII code something something. So you see, FsCheck is generating strings here, and it's generating like all the edge cases you could think of: ASCII, escape characters, non-letter characters. So it's really useful if you want to do like testing against a REST endpoint and you want to make sure it's really hardened and can handle all the edge cases. But in the case of Gilded Rose, or when you're generating coffee samples, those kind of strings are pretty bad. They're not self-explanatory. So we're going to show a way of composing different generators to make more meaningful coffee types and more meaningful item types. But the principle is, FsCheck, you don't write any code and it can generate magical objects for any type you can imagine. And we're going to leverage this to generate a whole lot of items for our golden master test now. So let's get rid of the coffee. Let's clear our REPL screen. And let's get started. So we want to have a whole lot of items. That's our goal here. So this list of items, we want to generate this using FsCheck. First, to get started, let's generate a single item. So let's make something called an item generator. Generator, and it generates items. There we go. Let's send this to the REPL. The type or nice. Oh yeah, I did not import the current project. So let's import this namespace, C#. That does not work because we don't know the current DLL. Can I send it through here? Is there a send to interactive on project level? Stop me if you see it. I'm not seeing it. Yeah, here, there we go. Initialize interactive with project. So then it loads all the things. Oh, that's even great. It loads FsCheck and everything. So now we have every reference we need. It's cool. So REPL knows about everything. Let's send item generator over to REPL. Oh, it still does not know about FsCheck. So let's import FsCheck. There we go. Now we can rerun that item generator. There we go. And we have an item generator, and let's sample some values for it. Let's generate 10 items. So these are 10 items, but they're really boring items. The name is N, the selling value is -1, quality is -2. So it's a really useless kind of item, especially if we go to the business logic. You see that these items all have, like, an item name is not just a string, apparently. There's these all kinds of special cases, and of course we would like to include these special cases in our test set as well. And if we are just going to wait until FsCheck generates a string containing the exact characters of aged brie, that won't be very effective, I think. So we're going to show a different way of generating items using FsCheck by helping FsCheck a bit. So let's even take a smaller step than trying to generate an item. Let's try to generate a valid item name. So we have a name generator. And you could do the same again, so generate a string, but we've seen before here, those item names or those strings it generates are not really interesting. So we're going to show another part of the FsCheck Generator API, and it's called gen. Yeah, this is the class or namespace gen, and it has a whole lot of functions. And one of those functions is called elements. There we go. And it takes a params or an enumerable of values, and it will return a generator that generates one of those values. So in the case of these item names, that's perfect. So for example, let's take aged brie. And another item name is backstage passes to some kind of concert, sure. And there was another one, sulphurous hand of Rose. Whoa. So these are the items in the code. Yep. And those are the 3 items that exist in the special cases. And for good measure, let's add a 4th one, namely my magical item down here. Let's add that one in the item names as well. So we have the non-edge case path as well. So let's send this to the REPL. Now we have a name generator, and if we ask this generator to generate some data, give me 3 item names, for example, it will give you 3 random item names. This is great. So now we can generate item names on the fly in one line of code. Okay, we can generate item names, we can generate items, but how can we generate items with those random item names? Well, this is where FsCheck's functional nature comes to show. It's a library for F#. F# is a functional programming language. And one of the main selling points of functional programming is you can compose everything because it has no side effects. You can compose all the things. Everything is a function, and you can give input functions to functions, and you can output new functions. And we're going to use this now to combine multiple generators into an item generator that suits our purposes. So, in order to do that, we're going to use link query syntax, because I hit the mic again, sorry. We're going to use link query syntax because I think that's the easiest to understand without having to earn a PhD in functional programming. So, how do you combine generators? First, I'm going to create another generator, one for the quality and the sell-in value. And you see sell-in value is an int, quality is an int. So I'm just gonna, I don't know if it's a good idea or not, but I'm gonna do a number generator. So we're gonna use this generator for both. And we are going to generate ints. We've used this before, I know. So let's send it to the REPL again. And let's see, number generator, give us a sample, give us some examples. Let's give me 10 numbers. Is this okay? It looks like interesting quality and sell-in values. Let's go to the code real quick. What are we seeing about these qualities and sell-ins? Quality around 50, that's an interesting case. Sell-in around 11. So we have to make sure our generators hit these kind of numbers. 50, 11, yeah, okay, cool. Currently, the random numbers look like they might not hit 50. Yeah. Maybe a quick peek. If you increase the size, you get bigger numbers. Yeah, okay, so we're gonna get there. But, okay, we have a generator for names, a generator for numbers, and we would like a generator for items based on those two generators we have before. How do you do this? It's really easy with link syntax. So link syntax is the from, select kind of thing. It looks like SQL, sorry, and it's C# code. So how does that work? From name in name generator. So this translates to when you run the name generator and extract one of the values out of it, you can bind it to this thing called name, and you can do something with it in a select statement. For example, create a new item object and give that item the name, that generated name we pulled out of the name generator over here. So this link statement is basically building a generator for items using the name generator to generate a random name and providing it. If you look at the type of item generator, it's not an item, it is a gen of item. So this is where the whole functional monad magic comes, but don't worry about that. This is just syntax to combine generators, let's call it that. So now we have a generator that builds on the name generator and generates items. Let's run that real quick. So name generator, item generator. Let's generate an item using the utility sample function. And you see it generates an item and it has really not interesting quality cell-in because we don't set those values, but it has an interesting name. It's one of those in the name generator. Now let's provide the items with interesting quality values. So from quality in number generator. So we just extract from number generator, which is an int generator, a random int, and we provide this as the quality field. Whoa, what's happening? There we go. Let's run this generator. Let's try it out again to make sure we're still on track. There we go. So it's generating a quality of -4. Looks good. Let's do the same for cell-in. So let's extract a cell-in value out of the number generator again. And let's assign this to the item. Quickly run it in the REPL. We have age3, cell-in 4, quality -3. It looks pretty good actually. Is it cell-in quality? I don't know which one is which. Interesting. Okay, never mind. So this is a generator of items and it will generate completely random based on this list names and completely random qualities and cell-in values based on this int generator. And this generates one item. But we don't need one item. We need a bucket load of items. So this is another utility function in FsCheck. Let's create a generator. And build upon that item generator we just created to create a list of item generator. And the way to do that is in the gen class again, or the gen namespace, you have a list of function. Yep. And you give it a list of given length. Interesting. Forget it. We're giving this another generator, so the generator for items. And if you look at the type of the items generator, it's a gen of blah 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 F# list, so it's a list for all intents and purposes of items. So this generator knows how to generate lists of items. Hey, that's exactly what we need. Cool. So instead of this hard-coded value of our hard-coded example, let's generate some items out of this generator. And you could do sample, but I don't think sample is deterministic. So let's give it a try here. If I run sample and rerun the sample, yeah, it's a different kind of item every time. That's something you don't need and can't use for a golden master testing. You need deterministic random data. And there's another function in there on generators. It's called eval. So it evaluates a generator and it takes two parameters, the size and a random generator, or a random number generator, sorry. So let's give it a size, more on that later, and a random number generator. I'm going to use another factory function new seed. No, make standard gen, yeah. So this is a random generator, and you can seed it. So you can give it a value, and every time you run this, it will return in the same sequence of random stuff. So let's send everything to the REPL again and try it out. There we go. So items should be a list of items. Yeah, it's a list of 5 items, namely HBRE, sulfurous, and some other HBRE, some more HBRE, some more sulfurous. So it looks like it's not really generating a whole lot of different items, so it's interesting, but okay, let's start. We have red squiggly lines in our test, and it's saying cannot convert F# list to list. That's technically correct, and F# list is not a list, but you can do something on this list, namely toListed, bam, and now it's a C# list like we all know and love, and Gilded Rose will accept it. So now we are generating random items, we are feeding them to Gilded Rose, and those generated items are deterministic, so are the same every time. It's exactly what we need. And we have our approval test around it, so let's just run it. And look at the diff, because I'm expecting this test to fail really bad. There we go. Okay, let's prove this. Copy, paste, bam, thank you. And if we rerun this test now, it should be green, should stay green, unless we introduce a bug. So I'm going to introduce a bug. No, I'm not. I'm going to show you later. So now we have a golden master. But is this golden master effective? Are we covering all the edge cases? Let's rerun our code coverage tool. There we go. We are hitting 49% of the code. I'll highlight it again real quick. So we are not hitting every branch in the code. That's too bad. We could fall back to providing manual cases again to cover all those special branches, or since we are brute forcing today using a FsCheck, why is this system string? Why are you in my face, system string? Okay, there we go. Since we are brute forcing item generation, there's a different approach, and that is to turn it up to 11 basically. If you increase this size parameter, FsCheck will generally generate longer strings, longer lists, bigger numbers, so it will increase the size of data that gets generated. So I'm just randomly running this, randomly increasing. So as you can see, this run is generating a lot more. So we're at some kind of, say, 600 items. So that's better. But the thing that's interesting for me is if I look at the quality and sell-in values, those keep being -1, 2, those keeps, they remain really small. So we're going to have to fix that first. It's generating small values, and if we look at where these values are coming from, sell-in and quality are coming from number generator, and that's just a generator for int, but that's apparently just generating little ints. And we need bigger numbers, because as we saw in the Gilded Rose class, interesting behavior happens around 0, but also around 50, around 11. We need a bit bigger numbers. So instead of a completely arbitrary random generator, let's make FsCheck, or let's make a somewhat smarter generator. And again, in the gen class, there is a utility function called choose, and you give it a lower and an upper bound, low and high. And for example, let's give it -50 to 100. So this builds generator that will return numbers in that range, so between -50 and 100 inclusive. That's way more interesting than what we had. And now if we rerun this test, we should get another diff, and hopefully the numbers look better. Actually, they look a lot better. Yep. Let's rerun the coverage report to see how much of the branches we're hitting. We are hitting 100% of the code branches. That's cool. So I'm going to make it a bit smaller data size to make sure, and see if we still hit 100%. Making it smaller is actually not that interesting. And just thinking performance-wise in a real scenario, it might be more interesting to have a smaller data set. But as you can see, this is not enough, so never mind. I'm just gonna roll back to the 1000 size we had to err on the safe side. Let's rerun the unit test to make sure we have 100% coverage. Unit test coverage is at 100% for Gilded Rose, yep. And let's approve this file by selecting the contents and pasting it into the golden master file. Now, if we rerun this test, it should be green, and it should be green every time because we are generating deterministic data. Cool. So now in theory we're done. We have a regression test net, and we can start refactoring. And for example, if I introduce a bug, let's say add another space here, so this check will start failing. If we rerun this golden master test, you will get a diff saying, whoa, something broke, and something broke with the backstage passes item. And you can see if you start to inspect every red line here, it goes wrong on some of the backstage item cases. Actually, I'm not going to stop here because it's even confusing to me. What's going wrong? You don't really know. So I'm going to do one more step. Let's first make sure we're back into green. Yep. Let's do one more step and provide a bit more context in that approved file. Because right now we're outputting the results, so the end state. So in the end, we provided some kind of HB item and we did the update quality on it. And these are the results, but we don't kind of know like which test case is triggered this kind of output. So let's capture that information as well, so we can provide more diagnostics in our golden masters. And to do that, if we look at how we are approving, you're just verifying like the toString of every item after we have updated the quality. Yeah, and let's do it a bit different. Let's capture the item information before we do any work on it, and then combine it with the item information after. So to do that, I'm just gonna let's first extract this. Yeah, extract item details. So this is the toString of every item after the fact. So let's call that after. Yeah. So after, cool. And let's do exactly the same before we run the code. So let's call this before. So now we have item details before and item details after. And let's combine those into some kind of meaningful text. Yeah, just gonna hijack this output. Let's combine these two. And how do you combine two lists? There's a nice link extension called .zip. You give zip a second list, so you give it after, and it will do an element-wise pair-up of those two lists. So it will take the first element of before and the first element of after, and you can do stuff with those tuples. So for example, the first before element, the first after element. And what do we want to do? We want to print out a string, printing out the before and the after on a single line. There we go. Then we want to, so what we have now is a list of strings again, containing the before and the after. And if we string join those two again, new line, so one line per item. What's wrong? I forgot a quote. There we go. So now we have this output that's saying a bit more. Let's run approval tests again to see if this new golden master looks interesting. And we have more interesting details, namely we have a before, HB of quality -11, and an after of -11. That looks really similar to the before, doesn't it? And actually, if I look at the outputs, every before looks exactly like the after. That's not good. Looks like we are doing something wrong. I see already. So items, we're doing this toString twice, but we're not doing it at the moment we expected. .select is enumerable stuff, yeah. So it returns an enumerable, and basically that means it's evaluated lazily, so not when you do the select, but when you use the select, and we use the select down here. So we are actually not capturing the string representation before. How do we force evaluation? By calling toList to make it eager. So let's do it there as well. So now we really have the strings before and we really have the strings after. We combine them and we approve this. Let's rerun the test to make sure. This looks better. So before HB of -44 and -13, and after the scenario ran, we had -45 and -11. So it looks like something is increasing for HB, but I think that's actually correct. And we have, how much data do we have? 600 and 600 plus items, so we still have that 100% coverage. I'm going to approve this. There we go. I'm going to rerun this test to make sure it's green. I'm going to rerun it again to make sure it's deterministic. And there we go. Now we have a really good regression net. And if we introduce bugs during refactoring, like I'm doing here, when we rerun our golden master test, we get a nice diff saying, hey, you remember those backstage passes of quality 74 and Selenium 3? Well, they used to give quality 48, so they increase in quality, but right now it's increasing twice. So that's not 3 times even. That's not what we want. So this showing the before and the after in a golden master file is kind of providing more diagnostics while you're troubleshooting behavior. So it's a nice way of making it easier to troubleshoot. And in the end, if you have a red test and really can't make sense of what is failing, there's a really easy fix, and that's just Ctrl-Z, undo, run your tests to make sure you're green again, and try again. So this was golden master testing using approval tests and FsCheck for data generation. Let's do a quick summary. What did we do today? We used approval tests to quickly write golden master style regression tests, and we made the output or the golden master file as self-explanatory as possible, so we had the before and the after in there to make troubleshooting a failing test much easier. Next, we used FsCheck data generators to generate a whole lot of random data without having to write a lot of code. So let's go back and take a look. We can generate 100 or 600 items in 4 lines of code. Sorry, 5 lines of code. So that's pretty nice actually. And this FsCheck library is highly composable. If you use that link syntax, you can generate generators, or you can build generators based on other generators. You can nest them as deep as you want. And if you provide a seeded random number generator, you can reproduce the results, so you have deterministic test data. Lastly, we used code coverage to check how much of the code we were hitting, and if we noticed like we were not hitting 100% of the branches, we increased that size parameter. We increased that size parameter over here of FsCheck to increase list sizes, increase numbers it generated until we had a data set large enough to cover every branch of code. If you see like increasing that size is not really helping because the edge case is that specific, you can always hard code a really specific item and put it in that list, or write a new test for that specific item to get to 100% in realistic legacy code scenarios. And that's basically it. So this was approval tests or golden master test using approval tests and FsCheck to generate a safety net around legacy code. And now you can get started refactoring without looking back and with a huge safety net in your back. Thanks for watching.